The activity series concept. When we have single replacement reactions, we have a metal replacing another metal in a compound. And we need to be able to predict if that reaction is actually going to happen or not. And so we use what's called an activity series that arranges metals in order of their ability to undergo reaction. So we list the most reactive metals first. Hydrogen is included only as a reference. And so the way this works is if metal A is more active than metal B, A will displace B from this compound. So this is where chemistry land party comes into play again. So here's metal A, guy A, and here's guy B, and here's the date, hot chick Z, right? And we want to predict who is she going to go home with. So if this was like a party situation, and there were these two guys, how would you decide which guy she might decide to go home with? You might look at the guys and kind of compare them, right? And the cooler looking one or the more macho guy, you might think, come on guys, work with me here. You look at people all the time and you think these things in your mind, right? Like, oh, he's hot, or oh my goodness, wow, can't believe he went outside in those clothes. We think things like that of other people, don't we? It's not always very nice, but we just need to be honest and it happens. This is like a list that maybe the high school girl is keeping of the finest guys at the school, right? And Lithium is the guy she'd really like to go home with, but if he's not at the party, maybe she'd settle for one of these other guys. So if this was, let's do an example here. If this was potassium and this was manganese, and we'll just leave her as Z. Is Z going to leave manganese for potassium? Well, we're going to look in the list. Potassium is number 2 in desirability, and manganese is down here. Yeah, there's going to be a chemical reaction, and manganese gets the girl, and poor potassium has to go home by himself. Yes, that's not how you do it. Thank you. That was completely wrong. Sorry. Potassium is the fine one, and he gets Z, and manganese has to go home. They don't just twist around like that. So this is, the ones that are closer to the top of the list are going to get the compound. They're going to get to be in the compound. Now, what if instead of potassium, what if this was copper? We're comparing copper and manganese. Here's manganese, here's copper. Is she going to leave manganese for copper? No. So then we say no reaction. Nothing happens. Iron metal will react with aqueous copper 2 sulfate because iron is above or before copper in the activity series. Of course, it has nothing to do with, lithium being a really cool, hot guy, but it does have to do with lithium being a more reactive and a more active metal. So we can predict that this will occur. If you put an iron nail in a solution of copper sulfate, you will get copper depositing on the nail. And the nail will slowly be eaten away as the iron goes off into solution with the sulfate ions. If you do it the other way around and put a piece of copper in a solution of aqueous iron 2 nitrate, nothing happens. Because iron is more active than copper. And there's yet another typo That is a subscript. We see this with acids, and this is the reason that hydrogen is in there at all. Hydrogen's over there on the left side of the periodic table with the metals, even though he's not a metal. He sometimes pretends he's a metal, and so he gets into this activity series. So we can compare iron and hydrogen on that list. And by the way, you do not have to memorize the list. I'll give you the whole list or a part of the list on the exam. I don't have it memorized myself, and so I'm not going to ask you to memorize it. It doesn't sound fun. But if we look on the list, iron is above hydrogen. Let's go back and look at the list. So here's the list, blah, 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 blah. There's iron, and further down the list is hydrogen. Iron is more active than hydrogen. So in this situation, iron is more active. He is going to displace the hydrogen. You'll end up with iron sulfate and hydrogen gas. They switch places. Copper does not react with sulfuric acid because copper is less active than hydrogen. So copper's coming in, hey, can I cut in? I want to dance with sulfate. And sulfate looks at copper, and she looks at hydrogen, and says, no, I like hydrogen better. He's more active. Maybe he's more fit, right? I used to say this is the list of ¿Quién es muy más macho? But most people aren't old enough to remember the Saturday Night Live skit with Ricardo Montalban and all of that, so I have to change it. There are a few metals, we call them active metals, that are so reactive they react with water. It doesn't even need to be an acid. They just react with water at room temperature. These are the active metals. It's the top 6: lithium, potassium, barium, strontium, calcium, and sodium. You put sodium in water, it basically explodes. And all of these guys will react with water. Nonmetals also have an activity series, but I guess we're not going to talk about them. So cool. Predict whether a reaction occurs or not. We don't have to write the equation. We're just going to predict if a reaction occurs. A gold ring is dropped into sulfuric acid. So gold is Au, because that's what you'd say if someone ran off with your gold, right? Hey, you, come back here with that. No. Sulfuric acid is H2SO4. So we're looking at hydrogen and gold. Who's more active? Hydrogen. So is sulfate going to stay with hydrogen, or is she going to go with gold? She's going to stay with hydrogen. No reaction. A zinc granule is dropped into hydrochloric acid. Any of these acids, it's hydrogen you're looking at. Who's more active, zinc or hydrogen? Zinc is more active. So what does that mean? Is there going to be a reaction? Yeah. She's going to drop hydrogen because zinc is a better looking guy, or he's more fit or whatever. So reaction. Cadmium foil, not Cadbury eggs, Easter's coming, cadmium, is put into a lead-2 nitrate solution. So lead-2 nitrate, PbNO3, 2, comparing cadmium and lead. Which is more active? Cadmium. Is cadmium going to displace the lead? Yes. So yes, that one will react. A chromium strip is put into water. This isn't acid, this is water. So then we have to ask ourselves, is chromium one of the active metals, the most active metals? It's these top 6. Is chromium one of those? No. Then no, it will not react with water. Those are the only metals that react with water at room temperature. Oops.